Okay, for ACF plot, choose that, and then time series, and then autocorrelation. So we choose the first data, the observed data, and click OK. So this is how the ACF looks like for the observed data. So we can see that the lags decreasing very slowly. And then we plot the ACF again for the difference data. So now it becomes like this. Okay, when we compare between the two, this is the real data of the observed data. Okay, and then this is after we take difference. So here, if we have this kind of plot or ACF, so we know that it has strong autocorrelation, and then means that it is not stationary. And then after differencing, we can see that there are only several lags that are significant. So here in the first lag, and then also several here. Okay, it's a bit seasonality, so it indicates there is a seasonality of the data. And then if we try to plot the PACF of the observed data, so if we compare the ACF and PACF of the data, of the observed data, so basically if the data has trend whereby it has strong autocorrelation, so basically we will have this kind of ACF and PACF. ACF will be decreasing very slowly, and then PACF is cut off at lag 1. So means here this is not stationary and it has strong autocorrelation. So means here that we can identify whether the data is stationary or not by using the time series plot and also the ACF and PACF plot. So here I has demonstrate to you how we are going to change the data from non-stationary into stationary by using the differencing. Now let's look at this model whereby we call it random walk model. So this is the model whereby we know that if the data has increasing or decreasing trend. Okay, so we take difference on the data on the series, so we denote as YT prime. So here means that we difference one time, just what I did just now. Okay, so we take the first leg of the differencing in the method just now. Okay, so YT prime is equal to YT minus the previous YT, means that YT minus YT1. So if the difference series is white noise, so we can write down the model as YT equal to YT minus 1 plus the ET. ET here is the white noise. So we can see that if we want to predict the YT or at time T, so we just simply take the previous one data, which is YT minus 1. Here we can see that this is similar to the naive method. Okay, so we can use this model we have learned in the previous chapter on the naive method. So there is another model whereby the difference is non-zero mean. Here means that if it is naive, so here is the ET, here is the white noise. Okay, if not, means that the mean is non-zero mean. Okay, non-zero means here, so we have a constant here, means that it is represent the average of the changes between consecutive observation. Okay, so it is average of the changes. This model we call it drift model. Let's move to the second topic, which is the second order differencing. Just now is the first order differencing, so we denote it as YT double prime. Let's recall just now, if YT prime, so it is equal to YT minus the previous one YT. So here is the first differencing. Now we difference it again. So means that from here we take double prime. So means that we differencing another time. So the first term here, the first term will become YT minus YT minus 1. and then the second term here, it will become yt minus 1 minus yt minus 2. We differencing this yt minus 1 time. So it will become yt minus 1 minus yt minus 2. So then we simplify, we will get this. So this is the first term, and then this is the second term. Okay, let's, if we have yt minus 2 and then we difference 1 time. So what will happen? So this will become yt minus 2 minus yt minus 3. Okay, then we have the seasonal differencing. Just now, if we different 1 time at non-seasonal lag, this will become yt minus 1. Okay, now because we differencing at seasonal lag, so it minus m, whereby m is the number of season. For example, let's say m is monthly, so m is 12. If we different 1 time at the seasonal lag, it should become yt prime equal to yt minus yt minus 12. Okay, instead of minus 1, now it is minus 12. So it minus t minus m. Okay, minus m depend on the seasonality. Okay, what if yt minus 1 and then differencing 1 time at seasonal lag? So it will become yt minus 1 and then minus, okay, m is 12. So it will become t minus 13. Then what happen if we differencing 2 times at seasonal lag? Okay, for example, the same example, m equal to 12. Okay, yt minus 1 double prime. So here, the first term, it will become yt minus 1 minus yt, okay, let's erase this first. Let's take the first differencing at the seasonal lag. Okay, taking from here, this one, okay, we take the second differencing at seasonal lag. Okay, so what will happen? Yt double prime equal to yt minus 12, okay, for the first term, and then second term yt minus 12 minus yt minus 24. Okay, so this is for the first term. Okay, taking from this one, yt. So we differencing again at the seasonal lag. So yt minus 12. And then for the second term, it is yt minus 12. So we differencing 1 time again at the seasonal lag. So it will become yt minus 12 minus yt minus 24. Then of course we can open the bracket. So how many times of differencing we want to take? So it depends on the data, on the suitability. So we will see in more detail for next topic. Okay, then that's it. Assalamualaikum and thank you.